Hello pre-calculus student, this video is for chapter 6.2, graph of secant and cosecant function. So we'll talk about how to graph secant function first. It turns out to graph secant function, we have to look at its reciprocal function cosine. So I'm going to get the table values of x and cosine. Actually, you know how to graph cosine, right? Cosine function is if you look at the unit circle, is the x value of the points of intersection of an angle to the unit circle. So at the main point, we have um, this is 1 comma 0. This is 0 comma is too small. I think I should make it bigger for the unit circle. Maybe draw it here so you can see it better. So the unit circle, this is 1 comma 0, 0 comma 1, 0 comma 1, negative 1 comma 0, 0 comma negative 1. So x is the cosine is the x value, so we say 0 pi over 2 pi, 3 pi over 2, 2 pi, right? So as at x equals 0, cosine is 1, and then this would be 0, and go to negative 1, 0, and 1. So what happens if you do reciprocal of it? It's still the same 1, right? At negative 1 is still negative 1, reciprocal of 1 is still 1. But what happens if it is pi over 2 and 3 pi over 2? It is undefined, just like in the um, tangent. So let's graph so that's what we know. At the point where cosine get 1 and negative 1 is they have the same value. So if I am to graph secant, I'm going to graph the cosine function first, which is like this, right? So the cosine function, I'm going to dot it because this is not the function that we're graphing, but we'll use it as a reference. And then on this side, we do the same thing. This is just the cosine that you know from long times ago, from 6.1. And then for our sine, for our secant function, I'm going to use the solid line, but this the 1 and negative 1, they have the same point. So this would be, the dots would be for the secant function. And then when the cosine function had a 0, which is the x-intercept, we have vertical asymptote. So I'm going to dot the vertical asymptote at the x-intercept of the cosine function. So you see that they're in pi over 2, negative pi over 2, just very similar to the tangent. Now to graph it, so what happened is when you have pi over 6 or pi over 4, the secant will be greater than 1. So it would be like this. They will go up. It's like a U shape, right? This is going down. This is going up. So the graph would be like this. Whenever you see a dot, when you see a loop, and between the two asymptote, you see a dot, you just curve up. And then this is a dot, and you have two asymptote, it curve down. So this is how you graph the secant. The secant function is this solid one. It's the same as the cosine at the tip of the wave, and it's go to infinity next to the asymptote. So we can actually study it. It still had the 2 pi. Vertical asymptote is pi over 2, negative pi over 2, 3 pi over 2, or pi over 2 plus m pi. Very similar to tangent. The domain will be x cannot be pi over 2 plus m pi. Range is from 1 to infinity, right? Because it can be 1 and infinity. And then it can be from negative 1 to, or from negative, okay, so from negative infinity to negative 1. So below, so there's nothing, negative infinity to negative 1. There's nothing in between 1 and negative 1. The same for cosecant. So secant function is 1 over sine. So if you have 0 pi over 2, pi, 3 pi over 2, 2 pi, the sign would be 0, 0, 0, right? And here would be 1, negative 1. So when you do cosecant, so this would be reciprocal is still 1, reciprocal is still negative 1, but this will be undefined. So be undefined as 0, pi, and all those 0, pi, 2 pi, 3 pi, this will be an asymptote. Okay, so let's graph the sine function as a reference function. So it should be like this, right? So we'll dot it. Dot it. Okay. And then we will dot the point for the cosecant function is the same at 1, negative 1, 1, negative 1, right? But then on the other one, we would know that it would curve up because when you divide, when you have 1 over 2 or 1 over root 2 over 2, they would be greater than 1. Like this. So basically you look at the 1 and negative 1, you know it is positive and it go to the two asymptotes going to infinity. Okay, so the graph would look like this. The period is 2 pi, vertical asymptote as 0 and pi, 2 pi, 3 pi, right? So it's n pi. Domain would be x cannot be n pi. Range is the same as the other one, from 1 to infinity and also from negative infinity to 1 to negative 1. And if you look at the shape of the graph, the cosecant function is an odd function, but the secant function is an even function, is a symmetrical left and right. Okay, so this is what it is. So what about some variation? If I have some a secant bx minus c plus d, how do I graph it? So what happens, you would graph the associated reciprocal function of cosine or sine first, and then you graph it by doing the dotted line. Okay, by doing the vertical asymptote at the intercept and then the U shape. So for example, I'm going to do 2 period of y equal to 2 secant pi over x. The associated reciprocal trig function is y equal to 2 cosine pi over 3x. Notice you don't have to change the 2 to 1/2. Just the same, 2 cosine pi. The only things you change is the function name. So everybody, after 6.1, you should know how to do 2 cosine pi over 3x. The amplitude is 2. Reflection is no. Period is 2 pi over 3, which is 6 pi. Phase shift is none because there's no c. So the whole graph would be, oh, not 6 pi, 6, because pi and pi cancel. So equal to 6. So 2, 4, 6. So this is one cycle, and it is a cosine. So cosine would have the, it is 2, right? So between 2 and negative 2, so would be highest here. Oh, and then 3 is the middle, right? Okay, 2, 1, 2, 1.5, 1.5, 4.5, right? So the same here. 6, right? So 3, and so this would be 1/4, 1/4, 4.5. So it would go dot 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 like this. Oh, okay, go up too much like that. We're talking about the cosine function. Okay, dot dot dot. And this would be the lowest. Go up and then okay, like that. So that's the cosine function. Is the same, like on and on. And then we are ready to do the secant. So first you do the dotted horizontal asymptote where there is intercept. I think there is an intercept here. It's intercept at 1.5, 4.5, right? All these. And then let me use another graph. So use this one. At the top of the graph, you will dot it. You will have a U shape. This would, oh, how come these are so close to each other? I did something wrong. So this would be another one like this. Oh, I think I make a mistake here. The graph, the scaling is not very good. So it's 3 because of 6. So this is 6. 3 is right in the middle, but the quarter point is hard to catch. Quarter point is 4.5. So again, this is 6. 3 in the middle, and then quarter point, quarter point. So let's do it again, and it's 2 and -2, right? 2, there's no reflection, so 2, this, this. So, and then this would be, go up 2. Okay, so let's dot it accurately. So that is the cosine graph. I'm going to use green for the second graph. So first of all the asymptote, 3, 4.5, 1.5, 3, I think, right? 3 is the middle, right? So then you would go up. So this is the point that is coincide. Whenever it's the highest point or lowest point, it coincides with it. There, that's the secant pi over 3x with a period of 6. The range is only from negative, okay, not like this. Start from negative infinity all the way only to -1. And then from 1 to infinity. Okay. Let's do a variation of cosecant. Cosecant is the reciprocal function is sine. So I would write -3 sine x minus pi over 4. Okay, so this is actually, that's what we need to graph. So amplitude is 3, reflection is none. Oh, the reflection is yes, because I have a -3. Period is 2 pi, because there's no b. b is 1, so 2 pi over 1 is still 1. Phase shift is pi over 4 to the right, because it's minus pi over 4. The vertical asymptotes are where? So it used to be, let's look at, it used to be at 0 and pi. So it will be, because you shift for pi over 4, so it'll be pi over 4. Pi over 4 plus pi. 5 pi over 4, that means. And then at the end, we should be 2 pi plus pi over 4 is 9 pi over 4. So there's actually 3 vertical asymptotes. So let's do pi over 4 is in the beginning because it's right. And then the quarter point. Okay, 5 over 4 and 2 pi. So base 9 pi over 4 should be here, right? So the middle would be this one, and this one is the quarter point. So at the beginning, it's gonna do down first. Go to the down -3 because the amplitude is 3 and -3. So it would go to -3, go back, go to 3 at this quarter point. No, is it 3? Yes. And then go to, yep. dotted. So this would be power of 4. So we have another one. Power of 2, power of 4. This is wrong. This looks wrong. 2 pi. So it should be a power of 2, but we shift to the right by 1, right? Technically, in the past, you would have it here and then go up. Now you shift to the right, so you go up here. Yeah, this one is not the right one. It should be here. So that's why we got it wrong. 3, right? Yeah. Right, and then like this. So if you do one more cycle, would be this one, 3, like that. 1, 2, 3, 4. Yeah, 1, 2, 3, 4. Okay, so now we're gonna do the asymptote. The asymptote, let's do green to do it, is when it's 0. So here we have power of 4, 5 power of 4, and 9 power of 4. The same here, right? So then you would do the loop. So mark the 0, mark the 1 and -1, and then do the loop. This is the same. Let's move up a little bit. Yeah, that's nicer. So long as you have the vertical asymptote and the 1 and -1 works okay, then you can graph it. So the green one is the cosecant function. And the asymptote is at 5 power of 4, power of 4. The range is the same. Oh, but because we do 3. Oh, the other one, did we do 2? Oh, right. Because amplitude is 2. So again, for the last one, should be -2 and 2. Yeah, because that's a amplitude. This one, we have an amplitude of 3. So the range is from -infinity to -3, union 3 to infinity. So there's nothing in between. Those are the sine graph. Yeah, the sine graph. The green one is the actual cosecant graph. So this is how you graph secant and cosecant. Basically, you graph a sine and cosine, and then you just U-shape it, and that would be it. When there is an asymptote, when there is a x-intercept, or when cosine or sine becomes 0, then you have a vertical asymptote.